Hello, guys. Good evening. Warmly welcome to the KT Sri Lanka monthly meetup. And today our topic is why do we even need Kubernetes? The today's session is conducted by the Ronak Banka, the DevOps Practice Lead at Temus. So today I'm full of curious regarding this topic. And now I'm invited to the Ronak Banka to conduct the session. Ronak,
Okay.
screen is yours.
Thanks, Harisha, for introduction and giving me the opportunity to be here. Okay. Let me share my slide. Okay, perfect. Thanks everyone for joining this stream. I'm sure you must be excited about this meetup. Me as well. So what we'll do is we'll discuss about why do we even need Kubernetes. Now, this is not a positive or like a negative statement, but we'll explore that. Okay, why people are talking about Kubernetes, how organizations are using it, and some of the related things. Before we start, a few things about me. So my name is Ronak Banka. I've been working in the platform engineering, DevOps, cloud domain for almost a decade now. Right now, I'm leading the DevOps practice, platform engineering practice at Temus in Singapore. I'm also a cloud native blogger and speaker. And when I'm not working on like technology, then I like traveling and travel hacking. So that's about me. Um, that's my QR code. So you can basically like scan the QR code. You can find all the details over there, like LinkedIn, Twitter, GitHub, whichever you follow. So we'll have those things on later on the slide as well if you don't get a chance to scan now. Okay, so let's go to the main topic. So what does our agenda look like? So our agenda is we'll talk about like what are modern applications. We'll talk about how containerization has helped. What is Kubernetes, and then later we'll open the floor to question and answer. Now, uh, the reason why we are not straight jumping into what is Kubernetes or what are the benefits or how organizations are using it, we want to take a step back to understand why people are even talking about it, right? Why there was all these discussions about cloud native applications or containerization and other orchestration and other things. So we'll start with that, and then basically we'll move to the Kubernetes part of it. So um, irrespective of whichever industry you are working in, there is a shift, there is a drive to modernize the applications. Like every organization, irrespective of whether they are like Fortune 500 or a startup, they are talking about how we can modernize our applications. Now, sure, how we can modernize is one question, but the main question is why we need to modernize our applications. So when we're talking about modernizing our applications, at the end, irrespective of whatever industry you're working in, we are trying to solve business problems for our customer. Now, the reason why I'm talking about these things is because we want to establish a connection between why we are talking about a certain technologies and what business problem and what user problem we are trying to solve with that. Now, for any industry, when we are talking about like traditional application portfolio, we were talking about system of records, which are mostly databases or maybe your like SAPs or other things. We are talking about systems of differentiation, your system of innovation. That's our traditional application portfolio. But now in modern world, in 21st century, when things are getting really fast, end users like even you or me, we are longing for a very different experience, right? We want similar experience, whether it is on our mobile apps or our tablets, or even our desktop or laptops, wherever you are accessing now, or even your watches like Apple Watch. So people want to have these different experiences. Now, when you want to have different experiences which should be seamless, it's not possible for you to get those experiences if your apps are not designed in that particular way, right? If you're talking about responsive apps, if you're talking about apps which are compatible across different devices, those are modern applications. We are looking at things like live feed, for example, this one, or we are talking about like any other live events, whether it is course or broadcasting or every other thing, those applications are designed in a way so that they can cater that particular requirement. If you are talking about like event driven applications, or if you are talking about highly scalable streaming applications, or maybe applications or like channels like which host your cricket commentary or your matches and all of those things, and those applications are designed in a way they can solve that particular purpose. So these modern applications have very different requirement than traditional applications, and that's why we are talking about why are we even talking about modernization, right? Why we are talking about the cloud native applications. Kubernetes is a way to run those applications, but it's good to understand why we are talking about those applications. Um, when we talk about modern applications, we talked about all these different kind of use cases. It's not easy to build these applications, or it's not easy to run these applications. So let's look into what are some of the challenges which we face when we talk about or when we are building modern applications. Um, because these modern applications are very much distributed, highly scalable, they require very different type of you can say compute or memory or scaling or even those kind of things. So some of the main challenges when it comes to modern apps are microservices complexity. Like if you have seen the diagram from Netflix in terms of their microservices architecture and complexity, it's huge. Same as with Amazon. So when these big organizations, when these big platforms are building these microservices applications, which are very complex, which are like maybe in hundreds in numbers, these applications are not easy to build, right? We talk about like inter-service communication when you are building, like let's assume we are talking about Netflix. When you are opening a Netflix account, it does like 10 different or 100 different things in the back end, whether it is your recommendation engine or whether it is your like where did you stop, or different users, or a particular country, what are the top movies or TV serials, and so on and so forth. So all these different things are possible because these different services are talking to each other, and that's not easy if you are talking about a very traditional world. Modern apps also like basically demand for isolation, security. Now, when we are talking about isolation, this is also in line with like how your resource allocation is done. Performance, if you are running too many applications in a system where you have issue of noisy neighbor, then you might not get that level of performance. We are talking about like scalability and resilience. We are talking about applications which can cater like millions and millions of users. I mean, if you have heard, like if you look at like Hotstar, which is one of the like streaming platforms in India, they were scaling like huge, like crazy whenever they used to host like cricket matches, or any other streaming platform like that. So I think these applications demand very highly scalable platforms, and not just like someone going in there and manually doing it. They require a more automated platform. Um, Resilience, definitely. Yeah, we don't want the users to like have any issues while they're accessing a system, irrespective of whether they are sitting. So even if something fails, our systems, these apps should be designed in a way that they can cater the audience. There is no service disruption. Modern apps, we are talking about public clouds, we are talking about private clouds. That opens like all new domain of multi-cloud deployment, like not putting all your eggs in one basket, like not deploying in one infrastructure or one platform or one cloud. Organizations are looking at deploying these applications across different clouds, and one of the reason for that is to avoid a single point of failure in the whole system. So even if something goes down, something happens on one of the cloud infrastructure platform, then your other deployment can basically like cater your traffic. So I think all these complexities are adding to the overall challenge. If we look at, we are talking about observability, how we are enabling our developers to troubleshoot, to understand how their apps are performing, pinpoint where exactly they are having any issues in the whole system. So I think these are some of the modern app challenges when we talk about the new era of applications. Um, Now we saw that there were a lot of challenges in the traditional world when we are trying to build such apps. Now, when people were having a lot of these issues, then instead of traditional way of deploying applications or traditional way of packaging application, we started moving towards containers. Now, what are containers? I'm not covering in that this particular presentation, but containers are basically processes. Now you're running these processes on host, and these containers are really fast, so you can basically tear them down. You can boot them up very quickly. And so look at let's see how containers help us. So there were few places where containers were really useful. So first one is portability. When we are talking about applications some time back, people used to run people used to build applications, and then they used to run across different environments. Now there were issues where these environments were not at parity, they were not identical, and people face issues saying that, okay, this app is running on my laptop, but this is not running in production, something like that. So when containerization came, when people started containerizing the applications, it allowed them to package the app in a certain way which can be deployed consistently irrespective of where you are running, whether it is on your on laptop or whether it is in production. That particular containerized application will behave in a similar way. Talking about efficiency, people were before, organizations were before running virtual machines, physical servers to deploy these applications. It took a while for virtual machines to start, but when containers came in, they basically gave a new way of deploying applications, which were very lightweight. Now, because of these lightweight containers, people were able to create and destroy them very quickly. They don't have to wait for minutes for a particular machine to be created. Um, because containers are designed in a way that they provide the isolation when running in an environment. Now, these isolations are at different levels. So these are also at the resources level, and these are also at the operating system level. So because of these different isolation, people were able to run applications in a more secure way. Also, it got really easy when talking about microservices, because then, when breaking an application in maybe 5 or 6 different microservices, you don't have to think how to deploy or how to package and run those applications. Those were very easily doable using containers. So you can package those individual applications as containers, and then you can run them as a stack. Um, when talking about cloud native applications, containers, Kubernetes, all of these things, it all started from a approach which was basically DevOps. Now, this was basically bringing in teams across different job functions to build a seamless experience. Now, having containers able to do some packaging and deployment and management, it helped to streamline some of those processes. Now, there was no manual basically throwing a ball on the other side. Once my application is packaged, someone is like, okay, can you deploy this application? We don't have to do that, because packaging and deployment can be managed by the container orchestration itself. So it helped us to improve the overall reliability of software, and we were able to ship the software much faster. um, okay, so we talked about cloud native applications, we talked about how containers help, maybe very briefly what are containers. Now when we are talking about container orchestration, or a place where we can run these environments. I mean, pretty much like everyone who is in this domain, either they have started or they know about or they have been working it for a while about Docker. So Docker basically started as a container, like Docker is basically a container runtime or orchestrator, which helps us to deploy or package our applications in a Docker or a OCI compatible image, and then you can run them on any container orchestrator. One such orchestrator was basically, or a platform was created by Google, which is known as Kubernetes. So, what does Kubernetes mean? So, in Greek, it means pilot. Like that's the term in Greek for Kubernetes. Um, but what it actually is. So Kubernetes started as a project inside Google. So Google was basically using Kubernetes to run their containers, like massive hundreds and thousands and like 100,000 and more containers within Google. And they were using this to run their different services. Maybe they were running, I don't know, what all Gmail or Google or whatever service, and we were using without knowing how those services were being operated or how those services are orchestrated and they were running. So I think these are all like projects which were already inside Google, and Google like decided to open source Kubernetes for a bigger community. But yeah, by definition, Kubernetes basically is an open source container orchestration platform used to manage and automate the deployment, scaling, and management of containerized applications. So that's by definition. We look into, okay, like how applications are deployed, or maybe how to actually like how what does those platform or Kubernetes looks like. Okay, so when we are discussing about um, all our containers and applications, we were talking about some of the challenges which we were facing or organizations were facing when running these new era of applications. And that's where Kubernetes helped to provide a lot of capabilities which were solving exactly those problems. So let's start with the very first one. Now, I, as a user, or you as a user, if you have to deploy an application, or if you have to containerize an application and then deploy somewhere, you you need an orchestration engine, and that's what Kubernetes is providing. It helps us to automate, scale, and manage the life cycle of your containerized application. So whatever applications you are trying to run, you can basically like containerize that application and tell Kubernetes that, okay, I want to run this application, and it will take care of all of those things. We are talking about like scalability. Like best thing about Kubernetes is that once you deploy the application, you can easily scale your applications horizontally. Now, the reason why we are not targeting like vertical scaling is because that's not how we want to design our modern applications. Like if your application is not designed to work in a horizontal scalable way, then that's an anti-pattern for a modern application, or to run on maybe any platform like Kubernetes or any container platform, because that's how we scale applications on container platform. We scale them horizontally so that they can solve or they can basically like serve more traffic. Um, Talking about high availability, um, I mean there were times in the past when people used to manually start and stop uh, like start and stop, we can say like virtual machines, which were not working because there was no way to detect or to reschedule our workloads, or you have to like manually deploy to a different machine and all of those things. That's not the case with Kubernetes. Kubernetes as a platform provides high availability out of the box. Now, when any application is deployed on the cluster, it basically detects and reschedules the workload. So the moment you deploy an application on a cluster, it detects that, okay, if like a particular like we can say a node is not working, then this particular platform makes sure that it redeploys your application on a different node. So that's from the high availability perspective. We are talking about resource optimization. If you are running thousands of applications on a cluster or across multiple clusters, you don't want them to basically like be a noisy neighbor, right? You want them to be you want them to be running in a way where they use the resources effectively. They are not basically consuming resources which were supposed to be for someone else. So platform or Kubernetes make sure that they are setting those limits. We're talking about service discovery or like load balancing and DNS related things, which are really important for applications or these microservices to communicate. Um, Now, when we are talking about like Kubernetes as a platform, it has inbuilt capabilities to provide like load balancing between different, we can say, pods. We look into that, what is a pod, but it basically that's like the very minimum instance of a particular application. So we are trying to build this thing, run an application, but we don't want to do all of these things manually. And that's where Kubernetes helps us to do all of those things. Talking about self-healing, I mean, like personally, even I remember when there were systems when like there was no self-healing because there is no control plane which is responsible to make sure that state is consistent. So you have to like go in and then maybe restart virtual machine or maybe restart some processes to bring back the system up, things like that. But now with containers, because there is a predictability that okay, like irrespective of where, when, and how, and like you run the container, it will give you exactly the same result. And that's why self healing is much easier now because it's not dependent on your runtime or it's not dependent on any manual configuration. You can basically just run your container and it will automatically run and the platform make sure it's self-healing in case of it crashes. Um, so these are like some of the like out of the box capabilities, but also when we are deploying or when we are building this platform based on Kubernetes within a bigger organization, there are a lot of systems which are external to the Kubernetes itself. So whether we are talking about maybe like external logging or monitoring, or we are talking about maybe like backup and restore, or we are talking about adding new capabilities, Kubernetes allows us to be extensible by having like plugins and extensions and things like operators using which you can deploy things very quickly. So these are some of the like main, or you can say like main important capabilities of Kubernetes, because of which it became a very strong competitor or a market leader in this domain of running your cloud native applications. Um, and the best thing about Kubernetes is that like scaling, high availability, all those things are important. But what on top of that, what it provides us is it exposes the same API for both applications and infrastructure, irrespective of cloud provider. So whether you deploy Kubernetes on Amazon or whether you deploy that on Azure or Google Cloud or DigitalOcean or whichever cloud provider, you will get the same experience. The APIs which are exposed by Kubernetes for deploying your applications, for creating any infrastructure resources, all of those APIs are same, and that's the main differentiator of Kubernetes as a platform. That you don't have to worry about different APIs across different environments. You can very easily run your applications across the cloud using the same API. So, what does the Kubernetes like cluster of like architecture looks like? We talked about all the capabilities. We talked about like API, but what does the cluster looks like? So, Kubernetes cluster, because like this might be still new to like some of the people on the stream. Kubernetes cluster is made of multiple objects, but like if you don't look at the diagram, you can basically think it in a way that when you are building a system where your state has to be maintained. Now, when I'm saying state has to be maintained, when you're deploying application, something or someone needs to make sure that your application is running in a consistent state. Now, that particular role is being played by control plane components in Kubernetes cluster. So, control plane components, which comprises of your API server, cloud controller manager, your scheduler, these components make sure that your applications are in consistent state. Also, these are the components which API server which exposes the API to your developer or whoever wants to use the cluster itself. Now we have the control plane, which is making sure that like our system or the state of our cluster is intact, running all the applications, making sure the like there is a health status and all of those things. Now, once we are communicating or once we are deploying any application using Kubernetes API, what it does is it sends those metadata, it sends that auction and other things to your nodes, which are basically worker nodes. Now, these worker nodes are the actual executor. These are the nodes which provides the runtime. So your control plane is something which is providing you with the APIs to interact, whereas your worker nodes are hosting these components which are known as kubelet or kubeproxy, which helps you to run and manage the traffic of your application. So anything which happens on a worker node is managed by kubelet. So all the communication with control plane happens via kubelet. And any traffic which is coming to your application is basically managed by kubeproxy. So these are some of the core components when we talk about like Kubernetes as like as software. Okay, so basically like cluster again, it's a collection of your host that aggregates the available resources. So that's worker nodes. We are talking about master, which is like building up the control plane, node, which is basically running your containers, and a namespace is something which is a logical separation or logical cluster or within the at that particular individual cluster. So that's a very high level components part. Now, so this might be little small, but what we'll do is, so when talking about application deployment on Kubernetes, there could be like 20, 30, maybe 100 or 1,000, whatever number, different ways of deploying. And now, when I'm saying different way of deploying, this is regarding the architecture. Now, your applications or the objects which are provided by Kubernetes, those are same. Like how you want to run your application, those constructs are same. Like it is like, okay, I want to create a deployment, I want to run an app, or I want to create an ingress, I want to create a pod, irrespective of whatever you want to do, those definitions are same. So in this case, for example, in this diagram, what we have is we have basically one application, or there are different microservices here. So we have a billing microservices, we have a shopping, a cart microservices, we have an inventory microservices. So we have like these different microservices which are talking to each other. Now, assume if you have to deploy this similar application outside Kubernetes on maybe a physical machines or virtual machines, imagine how much of effort that will take in terms of like basically creating all the connections or basically whatever firewalls you want or whatever like wherever you want to run those things, runtimes might be different. So I think that's where Kubernetes helped to improve this process a lot. How you would run these applications, how your applications connect with each other, how you are exposing your applications to outside world, how you are storing your secrets, or how you are automating the whole process. Now, because of the APIs, because of the standard APIs of Kubernetes, it became so easy for us, for any organization to basically plug in this whole deployment to a CI/CD tool. And there are dedicated tools like Spinnaker, which are responsible for the CD part of it. And then obviously there are like a lot of tools which are helping on the CI part as well. So I think because of these capabilities, because of this API, how we can deploy applications in a standardized way, it helped us to improve a lot. It helps us to ship the time, like basically reduce the time to ship the business value to a much lower time. So instead of spending like weeks and weeks for doing a production deploy, now it was possible for us to basically create like do a deployment in like minutes, because everything is predictable. Um, Now, what I've seen is, or probably you might have seen as well, a lot of organizations, a lot of people, they just want to use Kubernetes for the sake of using it, right? Like people might not evaluate it properly, or they don't know, okay, how you want to basically use it, or for what purpose you want to use it, and they just basically jump in and start using it. And when you do something like that, when you don't evaluate a technology properly, it becomes a technical debt, and you end up doing something like this, which is basically you have your huge Kubernetes cluster, and then you're just running your blog on top of it. Now, you could have run this blog on maybe like a simple WordPress, or maybe on like a simple static website on GitHub and S3 or whatever. But someone decided to run the blog on Kubernetes. And just because of that, like they end up creating a cluster and everything, which is a big technical debt, a very much overhead, because it's not required, because there is not enough complexity in there for which you are using a container orchestration like or platform like Kubernetes. Now, what are some of the use cases, what I've seen people using it, especially across the industry? So, e-commerce platform with multiple services. Now, we all know e-commerce platforms are huge. Like there are so many different functionalities, there are so many different personas or user flows which they're catering, whether it is payments, or whether it is product catalog, or authentication, or wallets, or recommendation engine, or maybe like displays or videos and all of those things. E-commerce websites are huge. So if you are building a product like this, then obviously you need a platform which can help you to easily scale and easily deploy your applications. Streaming platforms that need to handle like huge like traffic, and especially for special events. These are like applications which are like very ideal candidate for a platform like Kubernetes. Talking about machine learning applications, like those are like huge computational things. There are like a lot of like there are projects like Kubeflow, which is helping you to build some of those things on top of Kubernetes, some of those machine learning capabilities on top of the platform. So these are the use cases for which you basically select a platform like Kubernetes, large data scaling processing, things like that. But definitely not for running just a blog. Okay, so um, we talked about different things. We didn't go too deep into Kubernetes. There is like a lot of documentations which you can really use. What I wanted to focus in today's talk is more about why people are using this technology. What was the background? What was the challenges, and how it is helping to solve. Now, when like I said, people when you end up doing something like this is because you are not you are basically you haven't thought it through. So you are just thought, okay, I'll just use Kubernetes and then I'll deploy whatever I have to deploy on top of it, like without realizing that you are introducing a very complex system within your environment. Because, like, I mean, I think everyone, pretty much everyone in the industry knows that, like, it's not like easy to run Kubernetes in production, and especially when you are running at scale. You need people who understand the technology. You need people who are building on top of that, things like that. So that's why I was talking about this principle. So if you have like if you have read about like system designs and all, there is a principle known as KISS, KISS. Now, what does this principle stands for? So KISS stands for keep it simple, stupid. Now, um, when we are being asked to design something or architect something, or we have to visualize, right? We have to visualize what we are trying to build. Without that visualization, it's like super difficult to actually build something. Now, when you're trying to build something, if you're not keeping it simple, then you end up adding lot of complexity, because there are so many things which you can do, but you basically keep on adding things and keep on adding like technical debt. Because the more you add, it gets difficult for you to maintain it. Because until and unless you have a very big team who can spend time of each on each component and all, it's really difficult to maintain and build a mature platform like that. So it's really important for you to keep things simple. Basically use whatever is necessary instead of trying to pull in like all different projects, or whether it is Helm or Customize or any of those tooling. If you can directly deploy by kubectl, then you can deploy using the CLI. I mean, if it is solving your purpose over the time, if it gets more complex and you realize that, okay, I might need a Helm chart for this, right? People who are familiar with it, then you can go on that path. But you don't have to do that from the day one if you don't have that complexity. If it's that not your requirement. So that's why keeping it simple, it's really important across like any system. Um, if you have seen CFCF landscape, it's huge. It's like enormous. Like there are hundreds of projects over there for different purpose, but it's not possible for anyone to basically try all of them. That's not the goal. That's an anti-Python, right? I mean, you're just you're it's good to evaluate. You can probably try and evaluate, okay, what the particular software is doing, or what a particular like software is like what problem statement they are trying to solve. But then you don't have to bring in each and everything, right? You have to keep things simple, not run behind the landscape, just try to use every other shiny thing. Stick to the basics. I think that's really important when talking about platform like Kubernetes. So before jumping into more complex things like service mesh, or you are talking about maybe um, like other like complexities, whether it is sidecar, or we are talking about like other different projects in that domain. So I'll say like stick with the basics first if you're just getting started. um, Try to understand, okay, what how does the cluster works, what are some of the basic objects or definitions which are needed from like cluster operations perspective or application development perspective, deployment perspective. What are some of the tools which can help you getting started where you want to go? Instead of trying to choose the best one, most complex one, you can always try and like switch out if it doesn't work. um, Okay, so only deploy what you need, because if you keep on deploying things, then it will get off your hand. It will get out of your hand. Um, Okay. So how you can get it started? So there might be people on this stream who are still very new to Kubernetes. Like they haven't used it, or but they want to use it, or they want to do something with it. You can easily start working on your laptop on Kubernetes. You don't need to pay for public clouds or other services. You can easily start deploying the cluster on your platform on your own laptop with these different software. So there's Minikube, MicroK8s, there is Kind, there's K3s, Docker Desktop has inbuilt cluster. So you can use any of these software and options to actually deploy the cluster on your laptop, and then you can start playing with it just to see, okay, how this thing works. Um, okay, so I mean, that's definitely, I've seen this in the industry as well. What gives people feeling of power? Money, status, that's okay, but running your own Kubernetes cluster, people feel they have really, really amazing powers. Because it's definitely not easy to run and operate and build your own clusters. And when you are getting started, it's just one cluster, but then over the time when you grow, these may be like 8 to 10 different clusters, and then definitely you need some automation, or you need like some uh, kind of like tooling to make sure that yes, you are operating that particular system in the right way. Yeah, so I think that's what I've seen in the industry. And then, yeah, I think probably you're very familiar with this code. With great powers come great responsibility. Sure, it might be from Spider-Man, but it's also from like any Kubernetes engineer. So when you are building the platforms, right, you have to really think through from end user perspective. Now, end user in this case are application developers. So if you as a DevOps engineer or platform engineer are trying to build a platform, talk to your end users, talk to your developers on how they are planning to use it, what kind of features they are looking for. So think it from that particular mindset, not just like deploying any random thing. Like if your application doesn't need like mutual TLS or doesn't have any requirement to use service mesh, then I mean there is no point in using service mesh. You can easily run your applications with a simple ingress. So talk to your developers, talk to the application teams who are building these software, and try to understand how they are using the platform, so that you can better build these platforms for them. Yeah, so I think, yeah, so I'll keep it short so that we have maybe a little bit more time for Q&A. So yeah, that's basically from my side. Yeah, over to you, Kavish.
Yep. Thank you, Ronak. This is a Q&A time. If you have any questions, you can drop the questions inside the comment section. Uh, Comment section is open to you now. We'll give in a few minutes for your questions.
And these questions can be like anything. So if you're just getting started, it can be regarding that. If you're already, if you have, if your organization or team is already using it, then you can ask questions regarding that. So it doesn't have to be like related to this presentation itself. It can be in general as well.
Yep, Ronak, I have one question, and
Yeah.
if you can explain some certifications that conduct in the CNCF for the Kubernetes enthusiast, that will
Okay.
be great.
Okay, sure. Yeah, so there are three main certifications when it comes to Kubernetes. So there is CKA, which is Certified Kubernetes Administrator. There is CKAD, which is basically Certified Kubernetes Application Developer. And then there is CKS, which is Certified Kubernetes like security expert. kind of certification. So these are main, you can say, certifications which caters like most of the audience. Now, if you are an application developer, then you can target, you can say, like certified Kubernetes application developer, which basically helps you to understand, okay, how you can deploy your application, how you can better manage the overall features. So, for example, how you can maybe consume like persistent volumes, or how you can store secrets, or how you can do maybe like path-based routing on ingress, things like that. If you are more on the administration side, so if you are more on the platform side, operating the cluster, then you can target the like certified administrator course, which talks more, or like helps you to actually understand more from the like deep dive perspective. Like if something goes wrong, then how you can actually go and fix that thing. For that, you have to understand how these different components work within a cluster. Um, Also, I mean, irrespective of whether you are a developer or a like platform engineer, like if you are aware of like overall security posture and what all different capabilities are provided from the cluster itself, from the Kubernetes, then you can all obviously target the security specialist certification, which will help you to deep dive into the security aspect of the Kubernetes. So in terms of, okay, how the certifications are, like certificates are managed, or keys, or maybe encryption, and those kind of things. So I'll say those are three main certifications, and then there is also like Kubernetes and Cloud Native Associate, which gives you a like a different level of understanding to start. Yeah.
Yep. Well, thank you, Ronak. And I think time's up for Q&A.
Mhm.
For Q&A.
Okay.
Okay. Let's wrap up the session for today. And thank you, Ronak.
Okay, so there is
Practice.
one. So there is one question. Sorry to interrupt. So there is one question
Yeah.
from Daminda. I understand you're familiar with Tanzu. What's the best place to start Tanzu? Any similar playground? Yeah. So I think, okay. So like Tanzu being like Tanzu is basically like a bigger portfolio of products. So it's not just Kubernetes. Now, if we talk about Tanzu, there is a certain product which is known as Tanzu Kubernetes Grid, which is basically the Kubernetes offering within the Tanzu portfolio. So that's basically the core, like Tanzu Kubernetes Grid, which allows you to deploy your Kubernetes cluster on different clouds, even on your like basically you can deploy on AWS, or you can deploy on like other platforms. Like I'll say the best place to start is to actually go to the documentation. The public documentation has pretty much like everything to getting started. So you can deploy your basically CLIs and whatever the requirements are to deploy your first cluster. And then I'll say that follow the docs. I think like irrespective of whether it is Tanzu or like any other Kubernetes distro, I'll say that like going through the docs is the best way to understand any software, because the more you read the docs in detail, it helps you understand different things which are there in that particular platform. So yeah, I think probably I'll say that, yeah, for there is I don't remember if there is any like certain playground, Daminda, but yeah, I'll say like start with docs.
Thank you, Daminder, for your correction. Uh,
Yeah.
I think Ronak, that is it's from correction from comment section.
Okay.
Okay. Yeah. So we can wrap up the session for today. And thank you, Ronak, and the cloud practice lead at Temus. And we would like to bear with you for the sessions. And this is for our audience. Bear with us for more contents and more sessions in further. And thank you, Ronak, again. And see you
Yeah.
soon on the next monthly meetup. Thank you.
Okay.
Have a nice
Thanks. Thank you, Gorisha. Yeah. Thanks for having me. Bye.